In this video, we will discuss inscribed angles in circles. First, let's describe what an inscribed angle and intercepted arc is. An inscribed angle is an angle in a circle that has its vertex on the circle and the sides are chords of the circle. So if we look at this angle is an example of an inscribed angle because its sides are chords and the vertex of that circle of the angle is on the circle. Next, it says an intercepted arc of a circle is an arc of a circle having endpoints on the sides of an inscribed angle, and its other points are the interior of the circle. So if we look at something like we have below, this means that we have, in this example, we have the inscribed angle T and the intercepted arc UV. So we have UV as the intercepted arc, and the inscribed angle that goes with it is T. So the theorem associated with this says that the measure of an inscribed angle is half the measure of the intercepted arc. So if we have the angle as shown here, which is my angle B, it's 1/2 times the measure of the intercepted arc, which is AC. So to generalize this, we can say that the inscribed angle equals 1/2 times the intercepted arc. So using this formula, if I rewrite it, so we have that the inscribed angle equals 1/2 times the intercepted arc, I can look at what's given. So if I'm talking about angle P, I can identify my angle P as shown. So if this is my angle P, the intercepted arc that goes with that angle P is this length of MN. So if I were to write this as an equation for A, we could say that angle P, which we don't know, so I'm going to call this X, and using the fact that it's the angle equals 1/2 times the arc, I can substitute. So my angle in this case is, we're calling X. So I can say X equals 1/2 times the arc that goes with it, which is this value of 70. So X equals 1/2 times 70. Now if I plug this in my calculator, it gives me X equals 35, which means that the measure of angle P equals 35 degrees. Now for part B, it's asking us for the measure of arc PO. So if I'm talking about arc PO, and I pick that out on my diagram, I have that arc PO starts at P and goes over to O. And I don't know what that is, so I'm going to call this X. Or instead of calling it X, I've already used X, we're going to call it Y. The inscribed angle that goes with this arc is this angle PNO. So if I use the formula that the angle equals 1/2 times the arc, the angle in this case is the 56. So 56 equals 1/2 times the arc, which we can call Y. So equals 1/2 times Y. Now in order to solve, we have to get rid of the 1/2. So to do that, we can multiply both sides by 2, which cancels the 1/2. And if I multiply 2 times 56, gives me a value of 112 equals y, which means that the measure of arc PO equals 112 degrees. Now the next problem, we're still using the same formula, but we're just making it a little bit more complicated from how it appears. So the formula is that the angle equals 1/2 times the intercepted arc. Now, looking at what I have for A, we have that A is an intercepted arc. So it starts at P and goes over to T. Now, looking for the inscribed angle that goes with A, if I start at T and go across, I start at P, the other endpoint, going across, I see that I have this angle that goes with that arc, which has a measure of 60 degrees. So for A, if I use that formula, I'm going to have that the angle of 60 equals 1/2 times the arc, which is A. So now to solve, we're going to have to clear the fraction. So I can multiply both sides by 2, canceling the fraction. So it gives us 120 equals the value of A as the first part of our answer. So I can fill in the A equals 120. Now if I erase my highlighting to make it a little clearer to pick out what I'm talking about, the next part of the question asks for the value of B. Now if I'm looking at B, I can pick out that B is an inscribed angle. So here's my value of B. It's an inscribed angle, as shown from what I'm highlighting. And the intercepted arc that goes with B starts with P, goes all the way across to this S. Now the length of this whole arc is going to be the sum of the 120 and the 30. So if I were to add those two arcs together, 120 plus 30 gives you a value of 150. So this arc has a length of 150. So now if I use the formula, the angle equals 1/2 times the intercepted arc, we have that the angle is B equals 1/2 times the arc, which we said was 150. And now if you plug that in, that gives you a value of B equals 75. Now the following is corollaries to the inscribed angle theorem, which is essentially additional concepts that you have to know about the inscribed angle that come from that original theorem. The first says that two inscribed angles that intercept the same arc are congruent. The next says an angle inscribed in a semicircle is a right angle. And then the last corollary says the opposite angles of a quadrilateral inscribed in a circle are supplementary. And we'll talk about how these examples come up in the next couple of problems. Now, in this example, it asks to find the measure of the numbered angle. Now, using what's given, we have to find that the measure of angle 2. However, if we look at angle 2, we have that this is an inscribed angle and it intercepts this arc right here. However, we don't know what the arc or the angle is, so we can't actually solve. But if we were to work in with the other angle, we'll see that we also have another inscribed angle that intercepts the same angle. So if I were to use that, using the relationship, we know that the angle equals 1/2 times the arc. So we could say that the angle of 38 equals 1/2 times the arc, which we don't know, so I'm going to call that x. Now to solve, you would have to multiply both sides by 2, which gives you a value of 76. So this gives you that 76 equals x, which means that this angle over here is now, or the arc, is 76. Now working for the other angle, we know again that we have, now we can repeat that the angle should equal 1/2 times the arc. Now the angle we know is this angle 2. So I have the measure of angle 2 equals 1/2 times the arc, which we found to be this 76. So if I plug that in my calculator, you get the measure of angle 2 equals 38. Now this works, however, this is a long process to get the fact that these are the same angle measures. What you could do instead, without doing all this work, we could say that if I erase, we don't really need to do all this work. You could, there's nothing wrong with it, but the corollary that we found said that since these two angles intercept the same arc, we can assume that since this angle is 38, that this angle is also 38, based solely on the fact that their intercepted arc is the same for both of these. So we could say that the measure of angle 2 equals 38 without doing any work, and that's all based on corollary number 1. Now this example asks you to find the measure of angle A. Now, if we want to find the measure of angle A, we can determine that from looking at the diagram, if I have angle A, if I highlight this, angle A is an inscribed angle, and the intercepted arc that goes with A is this whole arc here. Now, because it is a semicircle, we can assume that the length of this arc is 180. So if I want to find the length of A, using my formula, says that the angle equals 1/2 times the arc. So if I substitute, the angle A equals 1/2 times the arc, which is 180, so that gives us that A equals 90. So I can fill in that this is 90. Now, to continue from there, we know that if I erase the highlighting of my angles that I have on the diagram, we now have a triangle. Now, we always know that all the angles in a triangle always add to 180. So if I want to find the missing angle in the triangle, if I call this x, I could say that 32 plus 90 plus x should add to equal 180. And if you solve, that'll give us that x is equal to 58. So I can now label that this angle here is 58. Now, if I want to look at B, for example, I can identify that B is an inscribed, or is an arc, as highlighted, and the inscribed angle that goes with B is this angle here, with the angle measure of 58. So if I want to solve for b using my formula, we know that the angle equals 1/2 times the arc. So if I substitute, the angle of 58 equals 1/2 times the arc, which is b. So if I want to solve, I have to multiply both sides by 2 to cancel the 1/2, and 2 times 58 gives you a value of 1/16. So 1/16 is equal to b. And this is another example of a problem using Corollary 2. Now the next example asks us to find the measure of all of the angles that are given. So if I look at what's given to me first, the first arc angle that's going to be the easiest to deal with is angle 4. Because if we look, angle 4 is an inscribed angle that intercepts this whole arc. Now we can combine the 60 and the 80 from these two arcs. And if I add the 60 plus 80, gives us a value of 140. So the measure of this whole arc is 140. Now if I use my formula, where we have the angle equals 1/2 times the arc, it would give us that the measure of angle 4 equals 1/2 times the arc of 140. So the measure of angle 4 equals 70. So now I can fill in that the measure of angle 4 is 70. Now using this, we know that the opposite angles should be supplementary, which means that this angle 4 of 70, the angle 2 should add to equal 180. That's what that corollary number 3 tells us. So if I were to use that, I could say that the 70 plus the measure of angle 2 should equal 180 because they're supplementary. The measure of angle 2 equals 110. So we know we have these two angles so far. So this angle is 110. Now let's say I choose to next start with angle 1. So if I pick angle 1, then angle 1 is given by this angle, and it intercepts this whole arc. You'll notice that this arc goes through the center, which means that it has a length of 180. So if I use my theorem that the angle should equal 1/2 times the arc for the second part of this problem, I could say that the measure of angle 1 should equal 1/2 times the arc of 180, giving you that the measure of angle 1 equals 90. So I can fill in that this is 90. Now the last part is I have to find the last angle in the figure, which we can do a couple of different ways. We could use the fact that all the angles in a quadrilateral should add to 360, or we could just simply use the fact that the opposite angles are supplementary. So we could use that this angle plus this angle should add to 180. So I could say that 90 plus the measure of angle 3 should equal 180. Or you could use the fact that they all should add to 360. So 90 plus 110 plus angle 3 plus 70 should add to equal 360. But either way you do it is going to give you a final answer that the measure of angle 3 equals 90, giving us the measure of all of our angles. The next question asks us to find the value of x and y. Now, if I look at my value for x, we have that x is an inscribed angle, as shown, and the intercepted arc is the arc DEF. Now, if I want to find the measurement of that arc, I'd have to add the 80 plus 70 because it's combining both of those measurements, which gives us a value of 150. So the measurement of this arc is 150. So if I want to use the formula that the angle equals 1/2 times the arc, the angle x equals 1/2 times the arc, which is 150. So this gives us that x equals 75, which I can fill in on the diagram. Now, if I look at y and I erase the highlighting on the drawing, my value of y is now an arc as well, and it is an inscribed angle, and it has an intercepted arc that starts at E, goes around to F, and back over to G. Now this arc includes the 70, but it also includes this length, which we don't know. But what we do know is that all the arcs in a circle should add to equal 360. So if I were to call this A, for example, you could say that 80 plus 70 plus A plus 90 should equal 360. So if I solve, this gives us that A equals 120. So now I can fill in that this length is 120, or the angle measure, arc measure. Now the measurement of this arc is going to combine the 120 and the 70. So if I were to add 70 plus 120, it gives us a value of 190. So that means that this whole arc has a value of 190. Now using the formula where we have the angle equals 1/2 times the arc, I have the angle is y equals 1/2 times the arc, which is 190, and 1/2 times 190 gives a value, so that y equals 95. So our answer is y is 95 and x is 75. Now in this slide, you'll see that in the diagram, B and C are fixed points, and A moves along the arc. Now with the inscribed angle theorem, we see that as this angle moves, the angle is 1/2 times the arc. So that should maintain as it moves. So I have point A here, it moves down to the point that it's over there. So I have this is my angle, and that's the arc that intercepts. So while it looks different, it uses the same relationship that we had before. Now, the theorem is essentially the same, it just looks kind of different. It tells us that the measure of the angle, which I can highlight as this is the angle, or this is the angle, equals 1/2 times the measure of the arc, whether this is our arc or this is our arc. Essentially, it's 1/2 times the arc it opens towards. So the formula we're using is still the same. It's just a different case of it. So it's the angle equals 1/2 times the arc. So in this example, we have an arc that is 160. We have an angle or a central angle that is 44 as given, which means that the arc measure is 44. So if I wanted to find the value of A, we can use the fact that we have this is an inscribed angle, A, and the intercepted arc is that 44. So using the formula, you can say that the angle equals 1/2 times the arc. So the angle is A equals 1/2 times the arc, which is 44. So A equals 22, which I can fill in on the diagram. Now the next part, if I erase this and just leave the values, we know that all the arcs in a circle should add to 360. So we could say that C plus 44 plus 160 should all add to equal 360. So if you solve, we have 360 minus 160 minus 44 gives us a value that C equals 156. So I have C is 156. Now the last example, or the last part, asks for the value of B. B is an inscribed angle, as shown, and the intercepted arc is this arc right here. And this is one of those special cases of inscribed angles. So now what we could do is we could say that using the formula, the angle equals 1/2 times the arc. The angle B should equal 1/2 times the arc of 156. So B should equal 78. So I have B is 78, A is 22, and C is 156.